Imagine the boardroom of a legacy Western automaker right now. Executives are crowded around a disassembled electric vehicle, staring at a motor and battery architecture that isn't just marginally better than their own, it's vastly cheaper, terrifyingly efficient, and ready for mass production. This isn't a futuristic concept rendering sitting on a server somewhere. It is physical, street-ready technology that is currently rolling off assembly lines in China. For years, Western companies have been locked in a grueling battle to shave fractions of a cent off battery costs and squeeze a few extra miles out of aging motor designs. But while they were iterating, a completely different game was being played on the other side of the world. A new breed of electric engine technology has quietly emerged, and it is powerful enough to give the biggest names in the industry, from Tesla to legacy European titans, absolute sleepless nights. Is this new engine truly capable of disrupting a century of automotive dominance? To understand the sheer scale of what is happening, we have to look past the sheet metal and understand the true story of this technology, the master-stroke strategy behind it, and why the global car industry is scrambling to catch up. The smog that sparked a 20-year master plan. If you look at any major auto show today, the underlying narrative is clear. The electric vehicle race is no longer just a battle of engineering. It is a battle of extreme long-term strategy. China didn't just wake up a few years ago and decide to build electric cars. They engineered the entire playing field. To understand the engines dominating today, we have to rewind a quarter century. About 20 to 25 years ago, China's hypergrowth came with a suffocating cost. Major metropolitan hubs like Beijing and Shanghai were perpetually shrouded in thick, toxic smog. Air quality was a full-blown public health crisis. Compounding this environmental disaster was a severe economic vulnerability: China's massive, growing reliance on imported heavy oil. The realization was stark. If China wanted to secure its economic and environmental future, its entire energy and transit system required a hard reset. Electric mobility wasn't viewed as a trendy alternative, it was a matter of national security. Back then, no one seriously believed EVs were the future for the masses. Batteries were prohibitively expensive, range anxiety was a very real barrier, and charging infrastructure simply did not exist. But the government took an unprecedented gamble. In 2001, through the ambitious 863 program, astronomical investments were funneled directly into high-tech and clean energy sectors. This was followed by aggressive new energy vehicle policies that championed battery electric, plug-in hybrid, and fuel cell vehicles. But the true genius of this rollout wasn't selling cars to the public, it was forcing the transition through public transit. The Shenzhen experiment. Instead of convincing skeptical consumers to buy expensive early-model EVs, China targeted public transportation. The city of Shenzhen became the ultimate proving ground, setting a radical goal to electrify its entire bus fleet. By 2017, an astonishing 16,000 buses had been fully converted to electric power. This wasn't just about cleaning up one city's air, it was a massive, highly visible proof of concept. It demonstrated to the world and to domestic consumers that large-scale electrification was not only possible, but reliable. Following this, the government tightened the screws on the industry by implementing a dual credit system. Automakers were legally mandated to produce a specific quota of EVs. If they fell short, they were forced to buy expensive credits from their competitors. The message to the industry was brutal but clear: build electric vehicles or face financial ruin. This policy sparked a violent surge in local innovation, driving up production volumes and aggressively pushing down manufacturing costs. Curing range anxiety, the infrastructure-first approach. While Western markets struggled with the chicken and egg dilemma, consumers won't buy EVs without chargers, and companies won't build chargers without EVs on the road, China simply built the infrastructure first. Today, millions of charging stations form a dense, inescapable grid across the country. In major Chinese cities, locating an EV charger is as frictionless as finding a traditional gas station. By systematically neutralizing the psychological barrier of range anxiety, they ensured that when the cars were finally affordable, the public was entirely comfortable making the switch. They built the confidence first and the vehicle second. The secret weapon: vertical integration and the permanent magnet motor. Now let's look under the hood at the real power, the technology driving these vehicles. If you want to understand why China is shaking the industry, you have to understand BYD. BYD is not a traditional automaker. It is an industrial leviathan that manufactures nearly everything entirely in-house. It doesn't just assemble cars, it builds the batteries, the electric motors, the sophisticated electronic control systems, and the microchips. This is the holy grail of manufacturing: vertical integration. When a company controls every single link in the chain, from raw chemical processing to the final dealership floor, costs plummet. This is the primary reason why Chinese EVs are hitting the market at price points that Western competitors literally cannot mathematically match. But freight operators are naturally skeptical people. They don't care about laboratory numbers or sterile test track conditions. The immediate question on everyone's mind was brutal. Is this just a fake, padded number? Because the real world is vicious. Trucks don't drive on perfectly flat, temperature-controlled treadmills. They haul maximum weight payloads. They fight through freezing blizzards that drain battery life. They push against aggressive headwinds. So how exactly did an electric truck suddenly quadruple the industry standard for range? Did they just strap a gigantic, impossibly heavy battery to the chassis? The answer is a masterclass in engineering. The secret wasn't just making the battery bigger, it was treating the entire vehicle like a hyper-efficient energy organism. First, consider the aerodynamics. Traditional diesel trucks look like giant brick walls moving down the highway. Their massive flat front grills fight the air, creating immense drag. It requires a horrific amount of fuel just to push that flat wall of metal through the wind. The 800-mile electric semi was designed more like a bullet. It slices through the air rather than fighting it. If you've ever tried riding a bicycle straight into a strong headwind, you know how exhausting it is. But if you tuck in and let the wind flow over you, the effort drops massively. By drastically reducing aerodynamic drag, the truck preserves a massive amount of battery life at highway speeds. Then comes the magic of regenerative braking. In a traditional diesel truck, hitting the brakes on a steep downhill slope generates terrifying amounts of heat. All the kinetic energy of that moving weight is completely wasted, burned off into the atmosphere. But in this new electric architecture, the motors run in reverse when the driver steps on the brake. Instead of wasting that energy, the truck actually captures the momentum of its own heavy load and feeds it directly back into the battery. The truck is literally recharging itself while driving down a mountain. Combine this with high-efficiency electric motors that waste virtually zero energy on friction or heat, unlike combustion engines which lose up to 70% of their energy just to heat and noise, and you suddenly have a machine that extracts maximum mileage out of every single kilowatt. But let's step away from the flashy technology for a second, because fleet owners don't buy trucks to save the environment or look cool. They buy trucks to make money, and this is where the real throat-cutting happens. In the logistics game, fuel is a nightmare. Diesel prices are wildly volatile, dictated by global politics, refinery shortages, and market crashes. It is a massive, unpredictable line item on a company's balance sheet. Furthermore, diesel engines are a mechanic's worst nightmare over the long term. They are incredibly complex metal puzzles filled with thousands of moving parts, transmissions, massive exhaust systems, complex cooling arrays, and constantly degrading oil. Every time a truck goes into the shop for an oil change or a transmission repair, the driver is sitting in a waiting room and the truck is bleeding money. The electric semi flips this economic model on its head. Electricity is significantly cheaper and far more price stable than diesel. But the real hidden killer is the maintenance. An electric drivetrain has a fraction of the moving parts of a diesel engine. There's no engine oil to change. There's no multi-gear transmission to violently strip and rebuild. The truck spends significantly less time in the mechanics bay and significantly more time on the asphalt, pulling freight and generating profit. We're now crossing the most critical threshold in any technological revolution, the transition from a cool idea to terrifying reality. We have moved past the concept art. We have moved past the hand-built prototypes. We are officially entering the mass production era. When you see factories being retooled and massive dedicated assembly lines firing up, it signals that the experimental phase is over. Major logistics conglomerates are no longer buying one or two of these electric beasts for a cute PR stunt. They are placing massive, multi-million-dollar fleet orders. When the biggest freight companies in the world start ordering in bulk, they are loudly declaring what they believe the future looks like. This has thrown legacy manufacturers into a desperate scramble. Companies that have dominated the highway for a century are suddenly finding their flagship products looking wildly outdated. They rushed out their own electric trucks to compete, but because they tried to retrofit diesel frameworks with new batteries, they're still stuck in that 200 to 300-mile trap. This new 800-mile electric semi isn't just competing with other trucks, it is actively rewriting the benchmark of what a commercial vehicle is supposed to be. It is shifting the entire conversation from can an EV replace diesel to how quickly can we replace all our diesels to stop losing money. But there is still one massive elephant in the room: infrastructure. You can have the greatest truck in the world, but if you can't charge it, it's just a very expensive paperweight. Charging a 40-ton commercial vehicle requires a terrifying amount of electricity. You can't just plug it into the same charger you use for a compact sedan. The solution to this isn't just building bigger public chargers, it's an entirely new philosophy called the depot charging model. Heavy-duty freight doesn't operate like a family taking a random road trip. Logistics are highly calculated. Trucks run designated routes and return to massive centralized hubs. By installing industrial-grade megachargers directly at these distribution depots, the trucks simply charge overnight or while they are being loaded and unloaded. The logistics depot of tomorrow isn't a parking lot, it's a decentralized power plant. The ripple effects of this transition are going to be felt across the entire planet. Heavy trucking accounts for a massive percentage of global oil demand. If millions of long-haul trucks transition from burning diesel to pulling electricity from the grid, the oil industry is going to face a demand shock unlike anything it has ever seen. Refineries, fuel supply chains, and global trade dynamics will be forced to adapt as the cost of transporting goods violently disconnects from the price of a barrel of oil. What we are witnessing isn't just the launch of a new vehicle. We are watching the foundation of the global economy being ripped up and rebuilt. The true electric vehicle revolution was never really about the cars sitting in traffic on city streets. The real revolution is happening right now, out on the open highway, where the true weight of the world is carried.